Dr. Hemalatha from K.B.N College in the Department of Physics and Electronics. I would like to discuss about AC generator, which is the important topic in applications of electricity and electronics of 5th semester physics. Firstly, I would like to explain about the generator. See, generator is a device. It is useful to convert energy from one state to another state. That means it works on the principle of law of conservation of energy. We all knew about the law of conservation of energy. Energy neither be created nor be destroyed. We can convert from one place to another place, one state to another state. Just like generator also converts the energy from mechanical state to electricity. Here, I would like to tell about the AC generator construction and working. So how it is constructed, on which basis it is working, and what is the output from the AC generator. See, AC generator is also a device. It converts mechanical energy into AC energy. Electricity is in two types, alternating energy and direct energy. From this generator, the output should be in the form of alternating current. It gives the energy in the form of output to the principle of electromagnetic induction. Firstly, what is electromagnetic induction? So, electromagnetic induction is the getting electricity by varying the magnetic field. That is the principle involved in the AC generator. So, this is the construction of AC generator. It mainly constructed with four parts. Those are armature and magnetic field that has been developed with two different poles of magnets, north and south pole. The armature has been fitted in between those two poles, and armature has an individual connection with the two slip rings S1 and S2. They are mobile bodies, and there are fixed bodies on the slip rings. Those are brushes. They are made with carbon material, and the final output from the AC generator has been collected through the brushes. So this is the information about the armature. So armature is made up of insulated copper wire. It has molded in rectangular shape. It has many windings. It has to make rotation with certain angle in certain times of intervals. It generates the mechanical energy. So the mechanical energy can be generated from the moving object. So we need to move the armature. We need to move the armature. We required some external force. That force has been from the magnetic field that has been generated the two poles of the magnets. So this is the diagram. The graph represents the rotation of the armature. Here the armature can make the rotation for every 90 degrees. Due to that rotation, the area of the coil has been changed. That changes the magnetic field of the coil, and that continues the changes in the flux. Changes in the flux develops the electromotive force of the coil. Electromotive force of the coil is nothing but the generation of current. So there is a standard relation for the electromotive force and the flux changes that has been given by the Faraday's law of electromagnetism. So here the coil has been moved from A to B with 90 degrees of angle. In that, the flux is continuously increasing. The coil makes another 90 degrees of angle, that is from B to C. Here the flux of the coil has been decreased, and it made another rotation from C to D with 90 degrees of angle. Here the flux of the coil has been reduced, and again it makes another rotation from D to A position with 90 degrees of angle. Here the flux has been increased. So due to the variation of flux, that develops the electromotive force. Development of electromotive force is nothing but the generation of the current. That is the principle involved in the AC generator. So the symbol in the screen is the representation of AC current. So this is the diagram. It represents the coil place and the magnet's place. So the coil has been placed in between two poles of the magnets, so that two poles generates the strong magnetic field. To make strong magnetic field, the coil has wound around a soft iron. So that strong magnetic field generates the magnetic flux. That flux helps to rotate the magnet, to rotate the coil. The rotation of coil is nothing but the generation of the mechanical energy. So while rotation of the coil, it changes the area of the coil. Area of the coil changes changes the magnetic flux of that coil. So magnetic flux generates the electromotive force. Electromotive force is the motion for the electrons. That is the process involved in the AC generator. So this diagram represents the remaining two parts in AC generator. So the red color parts are the slip rings. They had an individual connection with armature. So they are movable bodies. They are helpful to make rotation of the coil along the axis of the rotation. They can help to free rotation of the coil along the axis of the coil. And the black color bodies are the brushes. They are made with insulating material just like carbon. Why? Because from the brushes the current, the output from the generator has been collected. That's why they are made with insulation. Insulation protects the living bodies from the current. So this is the constructed body parts involved in the AC generator: armature, field magnets, slip rings and brushes. So the diagram represents the coil rotation. So the coil makes rotation for every 90 degrees of angle. For every angle, area of the coil has been changed. For first rotation, that is starts from 0 to A, the coil makes 90 degrees of angle. The flux of the coil has been raised, and then coil makes another rotation. The position of the coil has been changes. That changes the magnetic field of the coil, and that continues to change the magnetic flux. So the flux has been reduced, that has been shown on the graph. Next, third, the coil makes another rotation, that is from 180 degrees to 270 degrees. The flux has been reduced. And fourth rotation, the coil position from C to the graph position from C to D, the coil makes another 90 degrees. Here the flux has been increased. So due to the continuous rotation of the coil, electrons motion also continually varying, that produce the alternating current. Nowadays generators are very useful. We are all using current in nowadays, particularly alternating current. So generators are very useful. They are mainly useful in power stations. For power stations, they are backbones. For renewable energy power stations also they are useful. They are useful in winding turbines. They are useful in power plants to generate electricity. They are useful in home generators. They are useful in business purpose and also very useful in industries. Next, they are useful in automobiles. For continuous charging of battery and to power supply the vehicles, they are useful. They are useful just like lights, radios and other electronic features. And the main advantage or main application of generators is in industrial purpose or commercial use. So they are useful in machineries, motors, pumps and large air conditioning systems and also factories, and very useful in business purpose. They are useful for back powering sources for facilities like hospitals, and they provide emergency power in hospitals, and they are conventional power sources for back power. Next, they are very useful in holding appliances such as electronics, lighting, and other appliances. And they are also useful in locomotives. For diesel electronic locomotives, lightning to get lightning to communicate and to traction system. So these are the main advantages of AC generator. Thank you. Thanks to our management to give such a wonderful opportunity. Thank you.